We now talk about expectation of a binomial random variable x. So probability that x is equal to k, this is given as n choose k, p to the power of k times 1 minus p to the power of n minus k, where k could take value 0 or 1 or 2 or 3 all the way to n. So this n stands for number of trials, and the p here, this stands for the probability of success. So expectation of the random variable k is equal to 0 to n, that is all the values 0, 1, 2, 3 all the way to n, k times probability that x is equal to k. Now when k is 0, you have 0 times probability that x is equal to 0. Since you are multiplying with 0, that term will become 0, so it will not contribute anything. That is why we write this equal to summation k equals to 1 to n k times, and this is nothing but probability that x is equal to k. So I'm just copying this entire term right here. Now notice that k times, so this is nothing but k times n choose k, k times n choose k. This you can rewrite. So first focus on the denominator. You can do the cancellation. You get k minus 1 factorial right here. That is what you write here. And n factorial you can write as n times n minus 1 factorial. So therefore you can rewrite this entire thing as n times n minus 1 choose k minus 1. So what we have shown is that k times n choose k is equal to n times n minus 1 choose k minus 1, and that is what we plug in. Instead of k times n choose k, you plug in this. So that is what we get expectation of x as. We copy this entire thing down here and we get this result. So now you do change of variable. Instead of I, you put k minus 1. So first thing is we will take n and p common outside. So you take np outside, you will have p k minus 1 left inside. Now wherever there is k minus 1, you put I. So that's what we have done. So here there is k is equal to I plus 1. So you plug in I plus 1 here, you get n minus 1 minus I. Instead of k minus 1 here, you put in I. So notice that when k is 1, then I is 0. So when k is 1 here, you have I is 0 here. On the other hand, when k is n, I is n minus 1. So you get n minus 1 right here when k is n. Now notice this is nothing but binomial expansion. So this is binomial expansion of p plus 1 minus p to the power of n minus 1. So you are summing all the way from I equals to 0 to n minus 1, and this is nothing but 1 to the power of n minus 1, which is just 1. So you get expectation of x is n times p. Again notice that n is the number of trials. So n is the number of trials and p is the probability of success. Now we talk about expectation of a Poisson random variable x. So probability that x is equal to k for a Poisson random variable is given as exponential of minus lambda times lambda to the power of k divided by k factorial. And this k takes the values from 0, 1, 2, 3, 4 all the way to infinity. So expectation of the random variable is k times, this is nothing but probability that x is equal to k. So we are copying this formula down here. Now first thing you do is you cancel k with k factorial. You have k minus 1 factorial here. So that is what we have copied here. You take exponential of minus lambda outside and you take one of these lambdas from here. So you get lambda to the power of k minus 1 over k minus 1 factorial. Now you do change of variable, put I is equal to k minus 1. So when k is 1, in that case I is 0. And when k is infinite, very large number, then I will also be infinite. So you do the change of variable. So these two are copied as such, and you get summation I equals to 0 to infinity. So instead of k equals to 1, you have put I equals to 0. And this is nothing but exponential of lambda. So exponential of lambda times exponential of minus lambda will give you 1, and therefore this will be equal to lambda. So notice that exponential of minus lambda times exponential of lambda is equal to exponential of minus lambda plus lambda. This is exponential of 0, which will be 1.